So number 4, as we get bigger and bigger, what is this graph doing? Is it approaching infinity? Is it approaching 1? Is it not approaching anything? Or is it approaching -1?
It's not approaching anything.
Right, it's not approaching anything. The y value isn't approaching anything. X is getting bigger and bigger, but as it gets bigger and bigger, it's just oscillating back and forth. So there is no limit on that one. Number 5. Oh, this looks like another removable discontinuity kind of thing here. Because if x does not equal 1, then it equals this, but that can be factored and reduced. So factor the top. And I can go ahead and cancel the x minus 1s because it tells me that x isn't equal to 1.
Yeah.
So let's see what's going on here. The limit exists, f of 1 exists, f is continuous at x equals 1.
Well, the limit from the left and the right exists, but it doesn't agree, so...
Okay, so the limit from the left and right definitely exists because as we get closer to 1, let's see.
We get closer to 2.
We get closer to 2. 1 plus 1 is 2. So it looks like that.
But 4 is what x
So the limit exists. F of 1 is 4. That definitely exists. The number 2 is definitely true. F of 1 is 4.
3 isn't true.
But 3 is not true. It is not continuous.
There's an obvious hole.
Because the limit, for continuity to work, the limit exists, the function exists, and they're equal to each other. So the test for continuity is limit exists, function exists, but they're equal to each other. So 1 and 2 are true for this statement, but 3 is not true. All right, 6 is pretty much the same question. I don't remember if it works or not, but it's kind of the same thing. 7 is kind of the same thing as 4. So let's flip over to the back. And you should hope for 5 questions on limits with pictures, because this is supposed to be easy stuff, I think. Let's do number 8 together, and then I'll stop for a minute. So limit as x approaches 2 of f of x.
0.
What does that equal?
0.
0. So, because we're getting closer and closer to 0. It doesn't matter if we get there or not. So you try 8 through 12. They all go with that picture. We may get through all of them today. I feel like these are straightforward enough where we can pick on people. Certainly check with your neighbor if you're not sure. I know. You were the beneficiary of that switch off, Preston. So 8 was A, 9 was D, 10 was C, 11 was C, 12 was B. Looking at 13. Suppose all these limits. X approaches negative 3 from the left is negative 1. X approaches negative 3 from the right is negative 1. F of negative 3 is not defined. Which of the following statements must be true? I think I would draw a picture of that rather than just leave it at that. But so at negative 3, coming from the left, we reach negative 1. Coming from the right, we reach negative 1. And who knows what this looks like. But f of negative 3 is not defined, so there's no point anywhere for f of negative 3. So Roman numeral 1, as x approaches negative 3, the limit is negative 1. Is that true or false? That's true. If the left limit and the right limit are equal to each other, then the overall limit is the same thing. So we're good there. F is continuous everywhere except at x equals negative 3. What do we think about that statement?
That's not guaranteed, right?
I was going to say that's not guaranteed, like everywhere. Like,
We aren't given the function.
I don't know what's happening at x equals 2 or 7 or 10. Like, you
We are
know,
given the function.
maybe it's a jump or
Something.
who knows? Maybe it just stops somewhere. Like, I mean, maybe, but maybe not. So that's not true. It's not necessarily false, but it's not true. Must be true? No. Number 2, I don't know. We don't know. We just don't know. We know what's happening at negative 3. We don't really know anything else. So that everywhere thing throws number 2 out. Number 3, f has a removable discontinuity. Fancy word for hole. At x equals negative 3? Yes.
It does.
Yes. If the limit is the equal on both sides, but the function's not there, then yeah, that's a hole there. So 1 and 3 are true. 2 would be tempting, but you just don't know what's happening everywhere else.
We have problems 6 and 7 to do by ourselves.
So that leaves you with number 6 and number 7 to do on your own.